Hello everyone. So in the last video, um, we were able to complete all our API endpoints um, that happened to do with the to-do list. And last week in class, we connected those endpoints that we created and we made them more dynamic with our database. Not only did we do that, but we also learned about HTML, CSS, and some JavaScript in order to have a front end, right? That's what it's all about, connected to our API, which then would add content to our database. So I'll be going over that. I won't be coding along this time, as it is a lot that we covered, but I did do it on my own time. And you can also always go to Franklin's GitHub. And here we have the most up-to-date, but you can also try to figure it out on your own, which I think is the most important part. As long as we understand what is going on within the code, then I think you'll have no problem just trying to figure it out using documentation. This is the one for SQL model, of course, the fast API documentation, as well as MD and web docs, which is pretty much anything. This is the Mozilla documentation, so it's anything web related, CSS, HTML, and JavaScript. It's really good. You can look up anything, and that's awesome. Now let's go back. I'll start going along with the main. First of all, I changed the structure of our project, as you can see. Not everything is within the main anymore. We see that we have two main folders, right? We have our API and we have our front end. I'm sure you can guess what is in what, right? In our front end, we have our script for JavaScript, our CSS for styling, and our index HTML, the front page of our to-do website. So now let's look at what is different in our API section. Let's forget about this for 1 second. And let's just start scrolling down. As you can see, it's much more cleaner, right? It's more, it's split into 3 different files. And we have a more organized structure. Before we had the model and all the different functions within the main, which started to get cluttered if we ended up having a lot more functions, right? This is great because it decouples code. Which allows for reusability and calls from other files, etc. And that's a great practice. So we still have our get. We have all our create tasks, get tasks, update tasks, and delete, right? Now we have our model, which looks the same, except this time it connects to our database. It's no longer just a fast API or a base model, right? It's an SQL model, which does extend from fast API, but this is more geared towards, this is geared for SQL modeling. Now, if we look at the to-do services, these are the same functions that we had previously, except, once again, it's just a little bit tweaked for SQL, right? Now let's go over that. Let me close this. So the main difference is is that if you looked at my previous video, we were adding objects onto an array, right? That array won't exist once we close the application, right? When you close and run it again, everything that you added on the previous application runs. Arrays start to exist at compile time, and as soon as we shut our program down, then it won't longer exist, right? Because they are stored in RAM. So that's only temporary. With the databases, we're actually storing it in the hard drive itself. This is saved permanently, unless of course we delete the database. So that is a great feature that we're adding. When we close the program and we start it up, we'll still have the same information, right? It's like an Excel sheet. So that's the biggest difference that we did with this. Basically, we still have our previous endpoints, except this time they take a session. And a session is basically a temporary connection to the database that we're communicating with. And within that session, we can add, update, do all the crude methods that we do with HTTP methods, right? But with SQL. So we have to, of course, give a session for every single modification that we want to do for our APIs. And then we, of course, then have to execute the query that we want to do for that session. So with instead of doing the query or many queries one at a time, with sessions we can do them all at the same time, right? We can give multiple queries and then execute them when we think that our session is over. So here we're just selecting everything within our to-do database, right? And we can hover over this. We can see what to-do is, and it's just our object model, SQL model for our to-do database. Then here in get task, we do the exact same thing, right? I would try to go to SQL model, and the documentation will help you out. As I mentioned before, on things like how to retrieve data, how to add data, how to update and delete. And that's really all that we need for our project at this point. So our update to do here, this one's a little bit more complicated, so I'll talk about that. Here what we're saying is we want to select, well, first of all, start with the parameters, right? The name of this function is called update to do. So as you can guess, we're updating a specific to do task. We take a task ID, right, which is a primary key that is initialized by our insertion of a to do object. Then we give the one that we want to update, and then the session, of course, right? So this is the query that we want to run, one of the queries that we want to run. We want to select a to-do object where the to-do object is equal to the to-do task ID. So basically, we're looking for the one that matches the ID that we give it, right? Because we want to update. If it doesn't match, then there's nothing to update, and that would be an error, right? There's nothing to update. So we get the result by executing, that statement. And the current task is just 1. I believe if we just type in result, it would just return 1 anyway, right? Because there's only one object with that primary ID, but I guess that's just how you write it. I did this a few days ago, so I don't exactly remember. And then we retrieve the current task, right? We get its description and we set it equal to the description that we want to update, as well as the is complete, right? So maybe we have not checked it off, so we're updating it from false to true. And then all we do is we add it to the session, right? Think about it as a queue, and we commit it. So now this is us pushing it to the database. And then we refresh for our purposes in order to be able to return the most updated task, right? So which is what we were doing in this whole function. Now the delete works very similar, just less lines, right? We select, we take in an ID, which is an int, and then of course a session. And then we try to find a ID within the database that equals to the ID that we gave it. If this is true, we select that to-do object, we just retrieve 1, and then we delete it, right, within the session, and then we commit what we have done within the session. So now, because we have deleted, we have to tell the database, so we commit, similar to how Git works, right? We update it on the server, and now it's deleted. Let me go to the main. One thing that I'd like to emphasize is this is very important, as it's going to be a common error. CORS allows our backend to communicate with the front end, not at the moment, right? Because I haven't talked about the front end, but when we do get to the database, the front end stuff, then you're going to need this. So in our HTML, I'll just show you what it looks like, right? I think this would be better to look at visually. I have a header, and then I created a form where all it is, this is called a label, and it has an input of text with a button, right? And let me refresh this. Now, when I create the task, after adding it onto the server successfully, the database, this will return the success statement. So let's go back to our code. So that actually communicates with our database, and I will show you what it looks like. Oh, I already had it open, that's why. Okay. So as you can see, before I showed you guys, I did all these, and this is the one that I just inputted. So 0, some databases show false as 0, which is the same thing, and then true is 1. In the SQL workbench, it would show as true and false, so that's what you guys are doing it in. I like to use SQLite. That's just my personal preference, and it works the same way. So let's go to, I'll just briefly go over the code, right? We have a form. The IDs are important, and we'll see why in our JavaScript. And then our button, our input, which is required, and then our label. And then this is where we input like success or failure, etc. This is just basic styling. As you saw, my header was orange, so that's why this looks orange. Now let's ask ourselves how do these API calls get triggered, right? And I'll just play around with it. It gets triggered not when we click the text box, not when we type, but when we submit, right? So that's good. That's something to think about And it's something to think about because that's where we're going to be implementing, right? We have an event listener, and an event listener is basically a function that is only triggered when something or an event is going to occur, and there are many different types of events, right? There are on submit, which is what we have here. There is on click, hover, etc. There's a lot of them, and we can actually find them on the MDN docs that I showed you previously. So we select this task form ID, which is the whole form, and we wait for it to be submitted, right? And right here, we get the description of an element, which is a value, which its ID is description, and we print it. So I believe description is just the text box. Let me close this as well. Right, so basically when we submit, right here, when we submit, it'll console log. There we go. See, as we can see. Cool. So now we understand what this is. And now we're declaring the object that we're going to be passing on through JSON, right? Which is how our API takes information. This is pretty much what we did through Postman, the JSON development tool or API development tool. So as you can see, this follows the same structure, right? Description is complete, and this is how we create objects within JavaScript, hence why it's called JSON. So JSON uses the same structure as JavaScript to submit data, pass data through. So now we declare it, right? We declare task data, that is the object of our to-do item, pretty much. It's using the same structure. And we set description to contain the description that we inputted in the text box, and by default we create the is complete as false. We then do a try catch statement in order to make sure that our API calls work. If it doesn't, then that's what the catch statement is for. Otherwise, if it doesn't catch an error, then that is good, of course. And what we're doing here is we have to set this function as asynchronous, as we declared it here, because it's going outside of the JavaScript file, and we want to get information from our API, right? And it doesn't want to continue. We don't want it to continue compiling the rest of the lines until this is resolved. So what is this? It's our API call that we created. And that one is task create, so it should be right here. Basically, we're using the API endpoint that we created to pass it from here, and then it'll go to the backend here, and then this will resolve everything that we created before. So that would do create to do, which would be here, etc. And then it would go to the database, it would add it, and boom, now we have a fully functioning to do app. Not really, but we start to see it come to life. Anyways, it awaits a response from this endpoint, and we have to declare, we see that this is the structure of HTTP method. This is just how the fetch function works. We declare the method, which is a post, right? We're adding on to the database. We're sending the information from the front end and we're adding it to the database. The content type is JSON, and then this is the task data object that we created with the content that we inputted, and then we await its response. So success. I believe this doesn't even return anything, so I don't think we need to do that. And that's when we print out success over here. That's pretty much a whole walkthrough of our project. There are some things to note that I didn't show here, which you are supposed to do on your own, and that is setting up the database. I like to use SQLite, but you can use Workbench. Of course, making sure that the server is running. And if you're having some trouble with JavaScript doesn't help you out too much, or at least for me, when I create a typo. For example, I had text context instead of text content, and I spent some time trying to figure out this minor spelling mistake. So make sure that you are aware that not only is it case sensitive, but it doesn't help you out with spelling errors. Make sure that they are your path of the script and CSS are correct, right? That was a mistake that I saw very often. Another thing is, let me go back to the model. Make sure that your password is correct, and don't try to make a complicated password, because it just might get complicated. Yeah, so that is also some of the not major but common mistakes that I saw throughout the course last week. Thanks for following along. Bye.